Okay. All right. So a couple things. One is, let me talk about Google Colab. I don't know if you guys have heard of this. The Collaboratory by Google, and basically, you can create what looks like a Jupyter notebook, okay, but it's running on Google's thing, so you can run code, and basically it's Google Docs, but like a Jupyter notebook, okay? So multiple people can log in, collaborate on the same kind of notebook, similar to Google Docs. But it's kind of run and powered by this. And I didn't start off with this because I knew if I did this, everybody would just use this and avoid using Git and GitHub. But I think I really do think Git and GitHub is important and something that you should make use of. But for your projects and stuff, if you want to run it on the Collaboratory, that's fine. And there's an option to export it. And you can also save a copy in GitHub itself as well. So after you kind of run everything, you can save everything in GitHub. Right now it's free. And I think you can have, I'm not sure. I don't know about how much computing power they give you. I think for like most of your simple projects, most of your projects that you'll be doing, you probably don't need crazy amounts of computing power. So this is probably going to be adequate. But as if you ever scale up to something very big, then this might not be the appropriate platform. There's also a little bit of trickery, not trickery, but a little bit of a hurdle in that you have to upload your data to the Google Drive or something in order to get your data into the Collaboratory, because it's all powered on their cloud servers. But anyway, I'll put a link in here for I think it's collab.research.google.com. I think that's the address. Yeah, okay. And so that will kind of create it, and you can invite your friends to collaborate together on a single notebook if you are so inclined. Go ahead and log in. I'll add that to sounded funny. Okay, so I'll add a link to Google Colab. Let's get we'll do our online attendance poll. Take attendance today. Manage groups, no, manage classes. Okay. Oh, and then the other thing I wanted to point out was HackerRank. And I think there's another site, LeetCode, that I'll add a link to. These are just places where you can kind of practice coding and whatnot. You'll sign up in this code and get hired section, and they have these things where you can kind of practice. I've only done a few of these things, but they have little exercises that they'll present some kind of problem here, and then you write code to execute whatever task they've requested. This is mostly a coding practice tool, so it's not like quote like data science-y in that regard, but it's more of a general write some code to accomplish a task. But I think it's a pretty good website, and there's little coding challenges that will definitely test you and stretch you, and so I encourage that. If you want to get better at writing code, you want to get more comfortable writing Python, it's one of those things where, like playing a sport, you've got to practice a little bit, and you have to practice at a level that's a little bit harder than what you're comfortable with. Okay, you have to, if you want to improve, you've got to push yourself. And so with HackerRank, I think you can start off with easy questions, and it will code, and the questions scale up in difficulty. So there's that, and then I think the other site is LeetCode, and I'll add a link to this as well. Okay. We've only covered, just a few basic things as far as coding goes, and so, from here I kind of leave it, let you not run loose, but I'm not going to dwell a whole lot more on coding and stuff in Python. And so I have actually two notebooks labeled 0401. This is not really. This one's functions and Lambda functions. These are topics that we haven't, like Lambda functions, we haven't really covered in our class yet. And I'm not sure if we will entirely. So I think I'm going to go ahead and start talking about pandas today. But I've created this, just kind of as a reference. And again, you also have your access to, I don't know what happened here. Okay, the LeetCode website might be broken. But you also have access to those O'Reilly textbooks. And again, the two that I've recommended in the syllabus, the Python Data Science Handbook and Python for Data Analysis, I think are both very good, excellent resources for learning Python further. Okay. A lot of students ask, what should I do next? I truly believe these two textbooks, or the books from O'Reilly are very good. I don't even know if you'd call them a textbook. Okay, but I'll add a link to LeetCode, although their website seems to be broken at the moment, and it's just another place where you can practice coding, and I think they're all fairly language agnostic. Probably with a bent towards C++ and Python, and so you should be able to answer almost all of these things in Python. There's also discussion boards for when you get stuck. You can kind of take a peek at the discussion board. This is my advice though regarding HackerRank and in any of these places where there's discussion boards. On the discussion board, sometimes users will post the code answer directly. Okay. If let me just show you an example. So let's say you are trying out some kind of exercise, okay, and you can't figure this out. You read this thing and you're like, what? How am I supposed to do this? And you're not quite sure how to solve it. Okay, you can click over to discussions, and generally, a lot of times people will post the answer right here. Okay. Now, obviously, you can copy and paste this and submit the answer, and it'll give you the points for it, and your stars will increase or whatever on HackerRank. But obviously you're not learning by doing that, okay? But if you're truly stuck and you don't know how to solve a problem, I think it's okay to look at the answer to get an idea here, okay? But this is my recommendation, is look at the answer, study it, make sure you understand it, okay? And then do not answer the question that day. Come back the following day, all right? And that gives your brain enough kind of time to rest. And if you've forgotten how to do it by the following day, then that would be an indication that you didn't fully learn the solution, okay? But if the following day you remember the approach and the strategy you should take in writing your code, then go ahead and type in the code to answer the thing, okay? So if you want to look at the answers here in the discussion, I think that's okay. But again, look at the answer, study it, and understand it. But don't write the solution immediately after. Wait for the next day. Go back and find a different challenge to kind of answer. So that's my recommendation for this. This is just for your own benefit. I'm not like using this to grade you guys or anything like that. A thing about HackerRank is some companies have also implemented their technical interviews through the HackerRank interface. So some companies will will write up their own kind of problems to solve, and it will be implemented in HackerRank, and you'll log into HackerRank and you'll write up the code to solve their problem and challenge. So that's kind of a neat thing. So anyway, that's my recommendation there. Okay, other housekeeping things. Later on today, I'll go through the group sign up. So make sure your name appears on the sign up sheet. If it does not, I'm going to go through the roster and go through the sign up sheet. And if there's a mismatch, or if somebody's missing, I'm going to just assign them arbitrarily to a group. So if you don't want me to arbitrarily assign you, make sure your name appears somewhere on the group sign up sheet. Okay. All right, then let's get started. And so today we'll introduce pandas. This notebook is available for you to kind of just browse through regarding functions and Lambda functions. But again, I will not, I'm hoping what's happening in here is clear enough for you to follow along. But I'm not going to dwell a whole lot of time there. The matrix algebra, the @ sign is matrix multiplication as far as linear algebra goes. There's a few operators there. Let me go ahead and we're going to just click restart and clear all, and we'll work through this. Okay. Okay. So far we've covered in our class. Our first week was spent on Git. The following week was spent on introductory Python. And then we talked about NumPy, okay? And this week we'll introduce pandas, and we'll spend, I think, a fair amount of time on pandas because as far as Python goes, I think pandas is kind of going to be your primary tool to interact with data, okay? With data frames and things like that. NumPy is important because of the matrices and the quick numeric calculations that you can do in kind of vectorized form. And then, of course, the base Python language is also important. And then again, I'm working on creating a second homework assignment that will probably cover list comprehensions in NumPy. But today we'll start talking pandas. So in Python, in the base Python, vanilla Python, there's no data structure for a data frame, okay? And so pandas implements a way to create data frames, okay? Data frames being these two-dimensional tables, okay? You've got rows and you have columns, and they are set up so that each column is a single variable type, right? So much like a data frame in R, you have data frames in Pandas, and there's similarities, but also differences, okay? So I do believe that when you interact with data on Python, it's primarily going to be via Pandas, okay? And so Pandas runs on top of NumPy, okay? The columns are set up as kind of NumPy arrays, and the columns themselves are called series. So to get this running, you're gonna run these two lines of code: import NumPy as NP and import Pandas as PD. Okay, and again, these are just the conventions so that we're all kind of on the same page regarding the abbreviation for these modules that we import. Okay, so the kind of the basic data structure in Pandas is called the series, and the series is pretty much a NumPy array, except there's some meta information called the index. Okay, it's the index argument is optional, but Pandas will create one if you don't specify it. Okay, and so here I create a series called data, and I just take a list and I put it inside the pd.series function. All right, maybe I'll increase my font size. So kind of like the way we make a NumPy array, except it's pd.series for pandas.series. And then when you print out the series, it looks like this, okay? So here's the values, 0.25, 0.5, 0.751, and when I print it out, it comes out as, here, let me just comment that out. This is what it looks like. It's gonna say dtype float64. These are the data types. And then over on the left, it has created an index for us, okay? So it kind of prints it out like a column, and it shows us the index, okay? And then and the type that this thing is it's of the class pandas dot basically series, okay? It's a series thing, okay? If you do print.data, it comes out like this. In Jupyter, when you create a Jupyter notebook, if you just call the object itself, it comes out, it gets kind of this, I'm sorry. The series will just appear like this, okay? So when you just type out data and you just call the object itself, it appears like this. I think it used, no, I don't know, okay. The series has different attributes, and maybe I will okay, so you can just call the attributes, and the attributes themselves, I mean not the attributes, the values are an attribute of data that is stored as a NumPy array. Okay, so you can see if I ask for data.values, it's going to basically pull out, the values, and we can see that Python sees this as a NumPy array. Okay, and the index, on the other hand, show up as a range index object. Okay, start, stop, step 1, and this is shows up as a pandas range index object. Okay, and so the index is kind of one of the key things about pandas data frames, and it's a key distinction between data frames in R and data frames in Python. Okay, so data frames in R, if you remember, are list objects where you have vectors that are all of the same length, right? And R knows to treat this like a table. Okay, it's a little bit different in Python. In Python pandas, the data frame is this pandas object, and every column in the data frame is going to be a series, and every series has an index associated with it. And pandas uses the index to align values within the table. Okay, this will be made clear a little bit later. Okay, again, you can subset. Okay, so I could just say data single bracket 1. Okay, so here I'm asking, so here's data, and single bracket 1 basically references kind of the index there, and we can see that when you reference the object by using data single bracket 1, it simplifies it to just a floating float value. Okay, that's no longer it's not a series object, and it's not a array object. It's just a single floating point number, right? But here I'm selecting a range, and I say print data 1:3, and it returns exactly what we'd expect, rows 1 and 2 in the series, and we can see that this remains a series. So when you select only a single object, it'll simplify it down to kind of the element itself, and if you select a range, it maintains the series structure. Okay, and again, we can do fancy indexing, and we can say I want the values at index 1, index 0, and index 2. Okay, here I can specify the index myself. So here I'm creating a series object, same values, except now I provide the index itself, and so when I do this, I get that. Okay, and so we can see it puts this, and now it also provides the index names A, B, C, and D. Okay, the values remain the same. It's a NumPy array. The index is an index object with the strings A, B, C, and D. Okay, and now I have two options for subsetting. I can subset using square bracket 1, okay, and I can subset using the name. Okay, so I could say what is the object at index position 1, which is 0.5. What's the value or object at index name A, letter A, and that gives me 0.25 as well. Okay, I can slice just like before using the number indices, and I can also slice using the index names. Okay, so I can say slice A through C. When you use the names of an index, however, this is a key distinction, is that it includes the last one. Okay, so when you use index position 0:2, it goes 0, 1, up to, but not including 2. When you go name A:C, it goes A, B, up to, and including C. Okay, that's this can get confusing, especially if your names are numbers. So, okay. All right, here I've got a dictionary, and I can create a series with this as well. Okay, so I've got the name Archie, Betty, Veronica, Jughead, Cheryl, and the numbers or values associated with them are 70. These integer values. Okay, I can take this dictionary and throw it into a series, and I'll just ask, what does the series look like? Okay, so what it does is it's going to take the names and turn those into indices. Okay, so the index is Archie, Betty, Veronica, Jughead, and Cheryl, and then we just have the values. Okay, so if I say what's the index here, we're going to get an index object, and inside the index object it's going to look like a list with these string names, right? So we have an index object, with this. So we've taken the list and we've made it an index. The values themselves will be what kind of object? A NumPy array, right? A NumPy array with the values 71, 66, 62, and that's what we have, okay? All right. If I ask what's the type on the dictionary, what is Python going to tell me? It's going to tell me it's a dictionary, right? And then if I ask what's the type on the series, it's going to tell me it's a pandas series. Okay. All right. Here's another dictionary where I've got I'm using the same kind of indices, and then I'm using kind of the actor names. All right. And so so when I do this here, I've got another series, and so now we have a series thing. An interesting thing is that when you create create a series out of with string values, Pandas calls this data type object. Okay, so this is what we have. So over here we have data type our integers, int 64, 64-bit integers, and here I've got data type objects. Okay, so these are the names. Okay, and so here I have two series. Okay, I've got samp series, which is really the heights. Okay, I've got this series, and I have and this series. Okay, and you'll notice that this series, the names are in the order Archie, Betty, Veronica, Jughead, and Cheryl, whereas this series, the order is different. Okay, I've switched Jughead and Betty. Okay, so over here, this series goes Archie, Betty, Veronica, Jughead. I'm sorry, I don't know what I switched. I switched something. Okay, I changed the order. The index and the values here are different than the index, order of the index here. Do you guys see that? Okay, so this series has a different ordering than this. Okay, but if you create a data frame out of them, so a data frame consists of multiple series joined together, Pandas aligns them by the index. Okay, so it's going to go through here, and it's going to say, okay, I've got, I need to line up. So over here, Jughead has the value 72, and Jughead has the value Cole. They're on different lines, but it lines them up appropriately, okay? Because Pandas are powered by this index thing, okay? So all the series have an index associated with it, and so all operations regarding data frames make use of that index, okay? Whereas in R, if you just kind of took different vectors and you threw them into a data frame, they're just going to line them up in the order that they appear in each vector. Okay, Pandas is a little bit demands a little bit more in that it requires the index, but it also allows it to behave more intelligently in that it will line up the indices for you. Okay, so you have that. Okay. And so, and if we ask what is this thing, it's going to tell me it's a data frame object. Okay. Here's another way of creating a data frame. Okay, so this is going to be a list of dictionaries. Okay, so I've got dictionary A is 0, B is 0, A is 1, B is 2, and so on and so forth. Okay, I've got 3 dictionaries where they all have the same keys. Okay, and different values. Okay, so I've got a list of dictionaries. And I can throw in this list of dictionaries into the data frame, and Pandas will create a data frame object for us. Okay, here I specify the index to be 1, 2, 3 rather than the default, which would be index 0, 1, and 2. Okay, so the default is an integer index, a range index that starts off at 0, but here I'm specifying I want 1, 2, and 3. Okay, so here we go. And what it does is it basically turns every A value and makes a column or a series out of the values that are associated with the key A, and it takes all of the values that are associated with the key B, and it turns it into a pandas series, and it makes a column out of that. Okay. Over here, I do something similar, but you'll notice that the last dictionary in my list of dictionaries has a column C. Okay, so I've got A, B, and A, C. All right, and so I'm gonna kind of join these up. Okay, and I'm gonna say make a data frame out of this. All right, so what is this gonna do? What do you guys think? Okay, so it sees, you know, kind of 3 unique values here. Okay, and so it creates each one, gives each one its own column, so it lines up matches up all the A's, it matches up all the B's, and it matches up all the C's. But because we have missing values, right? We've got 3 columns and we've got missing values. It's going to throw in nans, okay, to indicate that these values are missing. We don't have a C value for the first 2 observations, and we don't have a B value for the 3rd observation. So it throws in nans. Now, one thing is that nan is always going to be what kind of data type? Nan is always a float, right? Nan is, you know, we learned is stored in the bits with, you know, all ones and something other than all zeros in the mantissa. And so nans will always be floats. And so here, the column A maintains its data type as integers, but then columns B and C get upcast into floats because it has to accommodate the nan. We don't have a missing value thing for integers, so they get converted into floats. Okay, and then also because I did not specify the index, my index is the default starting at 0, 1, and 2. Right. If we also want to create another dictionary manually here, I can just say A is 1, 2, 3, and B is the list XYZ, and oops. And so there's our dictionary there, and we can turn it into a data frame, and it's happy to do that. Okay. So here, when it returns the data frame directly, and if you don't call print, so when you call print on a data frame, it prints it out like this, kind of like maybe how R outputs it. If in Jupyter, if you just ask for the data frame to be returned directly, it gets kind of this fancy formatting where if you hover over it, it highlights the row and stuff. Okay, here I've got, I'm going to just take an array and make it 5 rows, 2 columns. So this is what I have, array of random values, and then I'm going to just say, here's our data frame, turn this NumPy array into a data frame, give the columns the names X and Y, and give the index the names A through E, okay? And it does that, okay? And then print again formats it like so. All right, so that's kind of creation of data frames. To be honest, probably though, you're gonna use read CSV with pandas to get data in. But I think it's important to understand how these data frame objects are created in the first place, and how they consist of series that are joined together and aligned based on their index. Okay, so here is the data frame that we've created earlier. Okay, this is kind of the Riverdale characters, their heights and their actor names. Okay, we can call, what are the keys here? Okay, the keys are basically the column names, all right? And you see that this is also an index object, okay? It's just an index object for the columns, okay? So we have an index, which is the names, Archie, Betty, Cheryl, Jughead, Veronica. We also have an index for the column names, okay? When you can extract the column. So here is the data frame using single square bracket. You provide it the column name, and it gives you back that. So this is probably familiar to users of R, because this is often how we can reference columns and things like that as well. Similarly, you have the dot to reference the column as well. Okay, so these two things are pretty much equivalent. So in R, you also have a similar operator, the $sign, to extract out a column, but in Pandas, it's just the dot. Okay, so you say the data frame name dot column name, and it will pull that out. Okay, what will Riverdale.actor single square bracket 1 pull? Okay, so it's going to reference the name at index 1, which will be Lily. Okay, and if I do Riverdale.actor and I throw in square bracket quote Jughead using the name there, what's that going to pull out? It's going to pull out the value associated there, right? Cole. Okay. This is the current data frame. You can also transpose it. Okay, and it does that as well. Okay. Let me. Okay, we have to subset. There are probably your two most important commands for subsetting on Pandas will be the .loc for .location and .iloc for index location. Okay, so .loc will pull out basically what is located at the index name. So the index name is Jughead, and it's going to pull out the value 72 and Cole, and it formats it as a series itself. Okay. So you can see that it's formatted as a series, and in fact, the values themselves appear as a NumPy array, which is strange because I've got an integer here and a string, and we know that NumPy arrays need to be of the same data type, and that is actually not 100% true. NumPy arrays usually are all of the same data type, but you can create typed NumPy arrays where you say in this array the first value, the value at index 0 will always be integer, and the value at index 1 will always be string. Okay, and you can create an array in that form, and NumPy can power that. Okay, so it is interesting that the values themselves are also a NumPy array, but they are what we call a structured NumPy array, which is still faster to compute than a list. Default Python lists allow mixed data types, but they don't specify that, you know, the first thing has to be this type, and the second thing has to be this type, and the next thing has to be this type. Okay, structured NumPy array, you know, says, you know, everything will follow this, and that's what we have here. You can subset based on a column. If you're going to subset based on a column, you need to throw in a colon, okay, for the loc. Okay, because if you do .loc, you can just pull out the index, and that's kind of its default behavior. If you want to pull out a column using .loc, you use a colon, comma, and then the column name. Okay. If you don't want to write a colon, comma, what do you do? If you just want to pull out the height column, what do we do? Just .height. Okay, like back here, you can just do .actor or something, or .height. Or you can use just single square brackets without the .loc. Okay, but if you use .loc, all right, it's gonna expect you to provide the index first. Okay, And then again, and now here I provide a coordinate, index Archie column height, and it pulls out the value there. Okay, so index Archie, where is it? Index Archie column height, and it's going to pull out that value 71. So that's .loc, all right, and this is probably going to be the most frequently used subsetting tool. Okay, other than .column name. Okay, so you've got, you know, data frame .column name. So here we did like Riverdale.actor or Riverdale.height, and it'll pull out that column. But then if you want to kind of pull out like a certain set of rows, .loc is probably going to be the one you use frequently. Okay, iloc will pull out based on index location. So here, if I do iloc3, it's going to pull out. So going back to the data frame, what is iloc3 going to pull? It's going to pull out index row location 3. Okay, so it's going to be the row for Jughead, and it's going to return 72 and Cole as a pandas series. Okay, so here we go. It does that. iloc 0, 1. Again, now we're providing it a pair of coordinates, so it's going to go to the top row, which is Archie, in the first column, index 1, which will be the actor name. So it'll be KJ there. Okay. Okay. Oh, great. Perfect timing this time. You can import data. This is probably what you'll use the most, read_CSV. I doubt you'll be creating your data frames manually by hand very often. And so here there's just a Titanic dataset CSV file, and you'll just use read.csv, okay? And so so it does that, and it creates object Titanic, okay? And so you can say, you know, Titanic.head. This is going to print out the top of the data frame, the first 5 rows, okay? And because I didn't specify an index, Pandas just gave me an index by default, right? So I've got 0, 1, 2, 3, 4 as kind of my my index, and that's what we have. This is something you got to get used to. Is you write the data frame name and then you do .head, okay? For everyone coming from R, we're accustomed to doing head and then parentheses, and then you put in the data frame name and it prints out the thing, right? And so this is always something that, as I'm switching between languages, I find myself typing head first, or in R, I'm doing the opposite and I'm doing something .head, okay? So, so .head, okay. Titanic.shape will give you what? The dimensions, how many rows, how many columns. So we have 891 rows, 11 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay. The columns will give you the names of the columns, okay. And so this looks like a list, but it's actually an index object, okay, because it's because again, everything in Pandas is powered by indices, okay, so we have that. I didn't do Titanic.index, but what will, let's go ahead and do that. Titanic.index, what will this return? It will say a range index from 0 to 891, step 1, okay? Okay. So it's it's another type of index object. Titanic.info is kind of like structure, where it gives you information about all of these things. Okay, so it gives you kind of the listing of all of the column names and what kind of values you have. And so you have integers and floats, and then here you have object. I guess the difference between object and string directly is that under object you can have, so these are basically this is string data, except you also have nans for missing, okay? And then Titanic.describe is kind of like a summary when you call it on a data frame, and it's going to go through all of the numeric what do you call it? The numeric columns and return summary statistics on those. Okay, so everything that's a numeric column, so it's not going to do it for sex and it's not going to do it for ticket, cabin, or embarked. Okay, but everything else that's integer or float, it's going to go ahead and count them up, return things like the mean, standard deviation, min, max, and things like that. Okay, so so you get all of these summary stats here as well. Okay, and so and the count here is excluding nan values. Okay, so without no missing values, and obviously that means these are calculated accordingly as well. Okay, so we're going to spend a lot of time on pandas. Pandas, there's a lot we can do. This is just kind of your introductory lesson on pandas, and we'll dwell here for a few weeks. Okay, okay, we'll see you guys on Wednesday.